This is AS2 Jun2009, and this is a question about the speed of sound. An experiment is conducted to measure the speed of sound in air using a resonance tube and tuning forks. The frequency of each tuning fork is recorded and the corresponding tube length at the first position of resonance measured. The data are recorded or is recorded in table 5.1. Calculate the values of one of the tube length and complete the row in table 5.1. And so all you have to do is 1 over the tube length, and that comes out as 3.2. Those are to 3 significant figures, so we'll just put them to 3 significant figures as well. 3.61, 3.88, 5.38, and 6.02. And then part B of the question asks you to plot this onto the graph. So these are the points that you're going to plot onto the graph. So the first one is 3.205 and 0.31, sorry, 256. So 3 point is about there and about here. Next one then is 3.61 and 2.88, and that works out to be about 280, about there. Actually a wee bit lower than that, maybe about there. The next one then is 320 and 3.88. So 3.88 first of all, there's 3.75, so 3.88 and 320 is there. So it's a wee bit over about here. The next one then is 5.38 and 456. So 5.38 is way over here. And what was the other one? 456. So 456. And so that's coming out about there. Just on underneath, about there. And the last one then is 512 and 6.02 and 512. 6.02 and 512. And that's about here. So okay, so you put a best line fit through those points there. And then it says measure the gradient of your graph and state a unit in which it is measured. Okay, so if you put a best line fit through that, it's coming out roughly about there. So, and then we have to get the gradient of the graph. So I'll just scan out a wee bit so you can see this a bit better. And so the gradient of the graph, I'm going to go from about here over to there, which is 260. So that's 520 up here and 260. So when I get the gradient of the graph, I have 520 minus 260 on the x-axis, on the y-axis, sorry, and on the x-axis then I have got 6.10. and I'm taking away 3.30. That comes out to be 92.9. Now, by the way, just when you do this, your triangle has to have a length here of more than 5 centimetres measured with a ruler. Otherwise, they won't give you showing you're working out there. So that's important that you do that. So the gradient then is 92.9, and it's measured in your frequency is in hertz divided by meters to the minus 1. So that becomes hertz meters. And then the last part of the question says, use a gradient to calculate the speed of sound in air. Well, we have got a graph there of 1 over L versus F. So if we write down V equals lambda F, we know for that first resonance position, lambda is equal to 4 times L. So V is equal to 4 times LF. But F is plotted against 1 over L, so it will bring the 4 and the L over. So V over 4 by 1 over L is equal to F. That's just bringing these over and then splitting that up there. And so that's what we have on our y-axis, that's what we have on our x-axis, and that's the gradient of your graph. So that means that V over 4 equals 92.9, and therefore V is 4 times that, which is 371.4. And that's the answer. And the acceptable answers were from 330 up to 375, so it's within the range.